to read this, but it's fine, I have the time to do that. I probably have to sit alone in this apartment rest of this year and most next year. I have to sit every day home alone next 500 days. So that's better, just make a new read list later. So I not just, this is the Wankel engine, then I not start to write like this and this and this, then there's no space enough. So we make a new one, start with this Wankel engine. I can already do that, no, but let's wait to do it. Let's wait to read it, finish, that would be a 9. Let's do the this Wankel engine. Read list and 17/6 the date 2022. So just do like this, but we have to read finish. So I don't go back to here, then I find some more there. Just continue there. So but we not finish reading. Yes. What do like this? Go there, Wankel engines. Just then go to read list 9. Then do something more here. But let's wait. We're not finished yet. But that sounds very good engine. But that's not always not the best. The auto industry using the best. But there's some kind of problems with this engine, why they not use it. That should have a higher emission, and maybe it's more expensive to make. So this engine sound very good, why they not use it in cars. But now we are year 2022, now I think about year 2030. It's not legal to sell combustion engines in Europe, in EU anymore. They will forbid it to sell it because they make the exhaust. Yes, but let's read it finish. I need to go to my bed. No, in 10 years it's maybe not legal anymore to sell cars with fossil fuel engines. Only in Europe, but of course you can buy it everywhere else.
In 2013, Ego Aeroplanes, based in Cambridge, United Kingdom, announced that its new single-seater Canard aircraft, the winner of a design competition to meet the new UK single-seat deregulated category, will be powered by a Wankel engine from Rotron Power, a specialist manufacturer of advanced rotary engines for unmanned aeronautical vehicle (UAV) applications. The first sale was 2016. The aircraft is expected to deliver 100 knots, 190 kilometers per hour, 120 miles per hour, cruise speed from a 30 HP, 22 kilowatts, Wankel engine with a fuel economy of 75 miles per gallon imp, 3.8 L /100 kilometer, 62 miles per gallon US, using standard motor gasoline, MOGAS, developing 22 kilowatts, 30 HP, 154, the 36E Star, an aircraft designed by Siemens, Diamond Aircraft and EADS, employs a series hybrid powertrain with the propeller being turned by a Siemens 70 kilowatts, 94 HP, electric motor. The aim is to reduce fuel consumption and emissions by up to 25%. An onboard 40 HP, 30 kilowatts, Austro engine's Wankel rotary engine and generator provides the electricity. A propeller speed reduction unit is eliminated. The electric motor uses electricity stored in batteries, with the generator engine off, to take off and climb, reducing sound emissions. The series hybrid powertrain using the Wankel engine reduces the weight of the plane by 100 kg compared with its predecessor. The 36E Star first flew in June 2013, making this the first ever flight of a series hybrid powertrain. Diamond Aircraft state that the technology using Wankel engines is scalable to a 100-seat aircraft. 155, 156, vehicle range extender. Structure of a series hybrid vehicle. The grey square represents a differential gear. An alternative arrangement, not shown, is to have electric motors at 2 or 4 wheels. Mazda 2 EV prototype. Due to the compact size and the high power Tau-8 ratio of a Wankel engine, it has been proposed for electric vehicles as range extender. So provides supplementary power when electric battery levels are low. There have been a number of concept cars incorporating a series hybrid powertrain arrangement. A Wankel engine used only as a generator has packaging, noise, vibration and weight distribution advantages when used in a vehicle, maximizing interior passenger and luggage space. The engine forward/generator may be at one end of the vehicle with the electric driving motors at the other, connected only by thin cables. Mitsuyo Hitomi, the global powertrain head of Mazda, stated, "A rotary engine is ideal as a range extender because it is compact and powerful, while generating low vibration." 157. In 2010, Audi unveiled a prototype series hybrid electric car, the A1 e-tron, that incorporated a small 250cc Wankel engine, running at 5,000 rpm, which recharged the car's batteries as needed, and provided electricity directly to the electric driving motor. 158, 159. In 2010, FEV Inc. said that in their prototype electric version of the Fiat 500, a Wankel engine would be used as a range extender. 160. In 2013, Valmet Automotive of Finland revealed a prototype car named the EVA, incorporating a Wankel-powered series hybrid powertrain car, utilizing an engine manufactured by the German company Wankel Supertech. 161. The UK company, Aero Radial Engines, offers a range extender based on the 294cc chamber go-kart engine. 162. Mazda of Japan ceased production of direct-drive Wankel engines within their model range in 2012, leaving the motor industry worldwide with no production cars using the engine. The company is continuing development of the next generation of their Wankel engines. The Skjoktafa Mazda states that Skjoktafa solves the 3 key issues with previous rotary engines: fuel economy, emissions and reliability. 24, 163, 164. Takashi Yamanaki, the global CEO of Mazda, said, "The rotary engine has very good dynamic performance, but it's not so good on economy when you accelerate and decelerate. However, with a range extender you can use a rotary engine at a constant 2,000 rpm, at its most efficient. It's compact, too." 73. No Wankel engine in this arrangement has yet been used in production vehicles or planes. However, in November 2013, Mazda announced to the Motoring Press a series hybrid prototype car, the Mazda 2 EV, using a Wankel engine as a range extender. The generator engine, located under the rear luggage floor, is a tiny, almost inaudible, single-rotor 330cc unit, generating 30 HP, 22 kilowatts, at 4,500 RPM and maintaining a continuous electric output of 20 kilowatt. 165, 166, 167. In October 2017, Mazda announced the rotary engine would be utilized in a hybrid car with 2019/20, the targeted introduction dates. 168, 157, 169. Mazda has undertaken research on spark-controlled compression ignition, SPCI, ignition on rotary engines, stating that any new rotary engines will incorporate SPCI. SPCI incorporates spark and compression ignition, combining the advantages of gasoline and diesel engines to achieve environmental power and fuel consumption goals. 81. Mazda confirmed that a rotary-equipped range-extended car would be launched a year late in 2020. There may be a choice of a larger battery bank to give full EV running with battery charging from the grid, with engine performing the dual functions of a range extender and battery charger when the battery charge is still low. When running on the engine, the electric motor is used to assist in acceleration and takeoff from stationary. 170. 26. Other uses. UAV 741 Wankel engine. 4 small Wankel engines are being found increasingly in other applications, such as go-karts. 171, 172, personal watercraft, and auxiliary power units for aircraft. 173, 174, Kawasaki patented mixture-cooled rotary engine, US patent 3991722. Japanese diesel engine manufacturer Yanmar and Doma Sachs of Germany had a rotary engine chainsaw, SAE paper 760,642, and outboard boat engines, and the French Altils Wolf made a lawnmower, Rotonda, powered by a Wankel rotary engine. To save on production costs, the rotor was in a horizontal position and there are no seals in the downside. The Graupner /O.S49 Pi is a 1.27 HP, 950 W, 5cc Wankel engine for model airplane use, which has been in production essentially unchanged since 1970. Even with a large muffler, the entire package weighs only 380 grams, 13 ounces. 175, 176. The simplicity of the Wankel engine makes it well suited for mini, micro, and micro-mini engine designs. The Microelectromechanical Systems, MEMS, Rotary Engine Lab at the University of California, Berkeley, has previously undertaken research towards the development of Wankel engines of down to 1 mm in diameter, with displacements less than 0.1 cc. Materials include silicon and motive power includes compressed air. The goal of such research was to eventually develop an internal combustion engine with ability to deliver 100 milliwatts of electrical power, with the engine itself serving as the rotor of the generator, with magnets built into the engine rotor itself. 177, 178. Development of the miniature Wankel engine stopped at UC Berkeley at the end of the DARPA contract. Miniature Wankel engines struggled to maintain compression due to sealing problems, similar to problems observed in the large-scale versions. In addition, miniature engines suffer from an adverse surface-to-volume ratio causing excess heat losses. To relatively large surface area of the combustion chamber walls transfers away what little heat is generated in small combustion volume, resulting in quenching and low efficiency.
Yes, but the power is red. No, let's just continue.
Ingersoll Rand built the largest ever Wankel engine, with 2 rotors, which was available between 1975 and 1985, producing 1,100 HP, 820 kilowatts. A 1-rotor version was available producing 550 HP, 410 kilowatts. The displacement per rotor was 41 liters, with each rotor being approximately 1 meter in diameter. The engine was derived from a previous, unsuccessful Curtiss-Wright design, which failed because of a well-known problem with all internal combustion engines. The fixed speed at which the flame front travels limits distance combustion can travel from the point of ignition in a given time, thereby limiting the maximum size of the cylinder or rotor chamber which can be used. This problem was solved by limiting the engine speed to only 1,200 rpm, 400 kilowatts per rotor, 179, and the use of natural gas as fuel. That was particularly well chosen, since one of the major uses of the engine was to drive compressors on natural gas pipelines. 180. The engines used homogeneous charge, and some ran for over 30,000 hours. 179. John Deere acquired the Curtiss-Wright rotary division in February 1984, also making large multi-fuel prototypes, some with an 11-liter rotor for large vehicles. 179, 149, 181. The developers attempted to solve their flame front issue, which hampered Ingersoll Rand's homogeneous combustion, by stratifying the fuel-length combustion chamber. 179. The technology was transferred to RPI in 1991.
Okay, do not see that. We have 2 minutes left on memory card. We have to stop recording. It's 4:10. I will start to upload 7 parts. We've got 2 minutes. I think I'd like to read this Wankel engine again later, so I need to make a new read list. I call read again. Read list, read again. We need to do that, but we are out of power. No, we're not out of power, but the memory card is full. So when I finish reading this, I need to make a new read list for that. And probably I will lose some 100 subscribers, 15,000. But we have to stop the video. We've got 1 minute left on the memory cards. I will go cook some soup. We got 1 minute left. Flashing. I will upload this charging camcorder. Then I will cook this potato soup. We can do that.